So in this video, we're going to talk about the principle of encapsulation. Encapsulation follows on very nicely from the notion of layering. In fact, encapsulation is a method that goes with layering in order to provide that layering separation of concerns. So the separation of concerns and responsibility in layering, as we've already seen, assigns specific responsibilities to different layers in the protocol stack. And as we saw in the model before, the physical layer at the bottom, the application layer at the top, allows each of those individual layers, the service that they provide, to evolve independently from each other. Examples that we've seen are the transport, allowing inter-application communication reliably in sequence. Any missing data is retransmitted. The link layer, where inter-host communication on a shared link, the communication between an end host and the router, or between successive pairs of routers. Encapsulation is a direct consequence of our use of layering. So it's how layering it manifests itself in the way that we represent the data at each successive layer. So layering data is the payload to layer n-1. What this means, and you can see in this this example here, at the bottom here, or in the middle here, we have the application data, which has been encapsulated into a segment which is for the transport layer. Here is the beginning, here is its payload, and here is its end. So the application data is sitting inside that segment. That segment then in turn is encapsulated or placed inside the datagram, which is for the network layer. And finally, that network layer datagram is placed inside that link layer frame, which is the one on the outside. So by placing each layer's data into the payload of the layer below, we construct a new frame or packet or datagram at that layer below to encapsulate that data above. So as examples, a web application's payload is then placed into a TCP transport segment, which is placed into an IP network packet, which in turn is placed into an Ethernet link frame.
One of the real powers of encapsulation is that it allows you to actually layer recursively. So far, the prior example showed this simple example where we have an application level payload inside a transport layer segment inside a network layer packet inside a link layer frame. But it turns out that if you want, you can actually start composing these layers in new ways to provide different kinds of services, and the encapsulation will work just fine. You can put something else inside an IP datagram network packet. You can put something else inside a transport layer segment. So let me give you one example of this, which is something called a virtual private network. So virtual private network is something which, say, often companies might use, where you have two different sites. Say I have site A, that spells site, and I have site B. And they are geographically distant. Like say, site B is on the East Coast and site A is on the West Coast. But I would like these two sites to be able to communicate with each other, so I can say easily transfer files between them. So I wanted these two networks, although they're geographically separate, to act like they are connected directly. Now I can't do this just over the internet by itself, because the internet is unsafe. There's all kinds of bad people out there. I can't just be transmitting my files over the internet freely. So what you do is you set up something called a virtual private network. And what you do is you have two gateways, one on site A and one on site B, and they open up a secure connection to one another. So something equivalent to, say, what you use with the HTTPS, with secure HTTP, using what's called a transport layer security socket. So now there's this secure, encrypted stream between these two gateways. And then when a computer on site B, let's call it lowercase b, wants to communicate with the computer on site A, what happens is its data goes into this gateway, where then it is encrypted and protected, travels over this stream to the gateway over in site A, where then the gateway delivers it to computer A. And so if you take a step back, what say is happening, let's say this node B is requesting a web page from node A. What's happening is you have an application payload, which is inside a TCP transport segment, because HTTP is over TCP. Right, so here's our HTTP payload, here's our transport segment, which is then being put into an IP packet, which is then, and that IP packet is destined to node A. that IP packet is then being put inside this secure tunnel, this secure virtual private network, which means that it's being put inside a presentation layer data unit, which is then put inside a TCP segment, which is then put inside an IP packet, which is then put inside an Ethernet frame. And so you can take these layers and actually employ them recursively, and encapsulation just allows you to do this trivially, where this is because of how layering maps to the data representation, because each layer has its own data format, and a payload to layer n, a data for layer n is just the payload to layer n-1, you can recompose the layers in this way, have the data formats work out, and it'll all work transparently, and the entire abstraction just falls out easily from the way in which you've coupled the data representation to the protocol layering. So in summary, encapsulation is the way in which we take layering and we manifest it in the data representation. We have all these protocol layers, and the responsibilities, ultimately they're adding bits or bytes to packets, and how do we lay those packets out in memory and out on the wire as we transmit them. Encapsulation allows the payloads of a particular layer to then provide the services of the layers above it. This helps the whole separation of concerns. My link layer doesn't at all care as to what the network layer packet format looks like. My network layer does not care at all what the transport layer packet format segment looks like. And this really allows you to enforce the boundaries between the layers, because if the link layer must be implemented such that it has no consideration as to what its payload is, then it is sort of, unless you make some cut some corners, it's decoupled from the network layer and is therefore independent of it. And this simplifies your implementations. You can just implement your link layer and implement it as well as you possibly can without having to worry about any of the complexities above.